You guys hear me okay? So we're going to start off by talking about, it's appropriate that we just came back from lunch because we're going to talk about how you feed the cloud. Because one of the most important places to begin using AWS is getting your data into AWS in Ingest. And you've got a lot of options there. S3 is the oldest service across AWS. We just turned 6 in February. So I'm going to take some time later in the presentation to talk about S3 so you understand its durability, because it's very important to how you scale on AWS. Before I do that, we want to walk through some options in terms of ingest. Now you can always go over the wire and move your data into AWS, into an S3 bucket, for example. But in some cases we have, especially in the media sector, customers that have acquired assets or have a massive one-time ingest that they need to do. And so we have a service called import-export. What you can do with import-export is you can ship us physical disk, and we will ingest that locally in an AWS region. And there are multiple regions around the globe that support import-export. So this is a way to both efficiently and inexpensively move large assets into AWS. We also do export jobs for disaster recovery testing as well, so we can move the assets onto a disk and ship it back out to you. So we see a lot of this being used, especially in the media sector, when you have big files that you need to move in. However, sometimes you need to have a second copy of your data. For disaster recovery purposes or backup purposes, we created the AWS Storage Gateway. So this is the first time that Amazon is inside your data center. So you can download this VMware gateway. It's a software gateway. Run it up on an instance of VMware, and your data will take a snapshot of that data, move it into the cloud, and you keep a copy on-prem. So pure disaster recovery play when you're using the gateway. Very inexpensive as well. So you probably are very familiar with gateways such as Symantec, Commvault, Nasuni, etc. So this is our own gateway. And the unique thing about using the gateway is when you do a snapshot, it's going into S3 in the form of an EBS snapshot. That means that if you needed to recover your application in the cloud, you can do so. Werner touched on that earlier today. So it's very inexpensive, about $125 a month, and you can get about 2 months for free if you want to do testing for second copy and using DR. Now, if you want it, in terms of doing it yourself on data ingest, there are different ways you can optimize your connectivity and your throughput into AWS. And one is using parallel uploads, where you can, when you parallelize your workloads, you're going to move the data ingest faster. Now, I've seen with customers using a direct connect line, I've seen speeds of up to 700 megabits per second over the internet using some partners, but when you're using a direct connect line like a gig-E or 10 gig-E, and direct connect would be provisioning a line directly from your data center into an AWS region, bypassing the internet. So for one media organization doing full feature films, moving over a single gig-E connection into S3, I've seen about 7 to 10 terabytes a day. And that's without using WAN acceleration, that's without using any type of compression, so just a straight connection. So you can move very large workloads from your prem into AWS, and Direct Connect is going to give you that consistent latency. You know your experience because you're not going over the internet. However, if you want to turbocharge your Direct Connect or your internet connection to AWS, you can turn to a partner like Aspera, and I wanted to turn over to Michelle so she can walk you through the value proposition for Aspera in AWS.
Thanks very much, Joe. I'm actually going to be doing some demos, so I'll be over here at my Mac. So just to give you a little bit of background on my story today, I want to really dovetail with something that Werner talked about earlier, and that's the innovation that the Amazon AWS platform has enabled. For our company about 2 years ago, the advent of the Amazon cloud caused some of our customers, Amazon themselves in the video side, Netflix, for example, to approach us about adapting our core transport software, which is used for high-speed bulk data transfer, to native integration with object storage, and in the case of Amazon, integration directly with S3. And the reason that was so important is because the workloads were shifting from on-premise into cloud-based environments. And to put a fine point on that, about 2 years ago is when Netflix was contemplating moving their transcoding workflows that were largely done previously on-premise up to the Amazon cloud, continuing to scale that out, and then secondarily also eliminating the 2 steps in the transfer process that would ingest content to bring that directly up to S3. And one of the things that might not be so obvious on the surface is that this type of integration isn't the same as working directly against a regular file system. Object storage has very unique characteristics. It's distributed by definition, so there's a wide area movement problem, and then the nature of the storage itself is such that big files are somewhat incongruent with it. And so what I want to talk about today is what we've done at Aspera to natively enable the Aspera fast transport for object storage, and particularly Amazon S3. What we've tried to do in this is preserve the same performance, the same security, and the same predictability that you've experienced, hopefully, with our software in the on-premise and traditional file system contexts. The other thing about this is we've also tried to preserve the application experience. So the APIs and the clients that you would have already deployed from Aspera will be perfectly seamless with this. And I want to say special thank you to our customers who've worked with us over the last now year and a half to get this fully productized. Several of them have commented today, and I really appreciate that because this has really been a grand experiment that has turned out tremendously successfully for us, and we're looking forward to the next stages. So for my talk today, I want to go over a little bit about the problem of big data transport in the cloud, and then I'm going to spend some time showing you the exact solution that we've created. If I have enough time, I will also do some demonstrations of that, and I want to explain a couple of key use cases. One will follow me later from the UFC. He'll tell you directly their user experience. I want to talk a bit about Euro 2012, which took place this summer and interestingly did a very large part of their content distribution off of AWS. So I think if I can get this to clicker to advance. Get a little help on the AV side to advance the slide. Just go this way. So I think most people know what we're involved in here at Aspera, and that's creating transport technologies that deal with the basic problems of moving large data. And as we've talked about here, one of the most basic things that happens when you try to access the cloud is that you're at distance. Also, the data sets keep growing ever larger, and so you put those things together and you're left with a wide area problem combined with the object storage and also a lot of data. And specifically in terms of the technology side, you might wonder, well, what does this really mean in terms of the way the technology works and what does it deliver? And we'll be talking about this as I get into some of the problem space. The Aspera Fast technology is an innovation in transport that allows for predictable throughput at full available bandwidth capacity, independent of network delay and packet loss. And the reason for that is simply the behavior of the transport itself in terms of how it sends data over IP networks. Now, the key parts of that are to not only do that at speed, but to be able to protect the network while that's taking place, and then to be able to scale up and down as network resources and storage resources are shared among many transfers and many applications. So we create a software platform of tools and applications and an SDK that builds on this type of transport technology to move large file data and sets of file data around wide area networks. And that then brings us into this situation with object storage. So about 2 years ago, Amazon introduced an interesting advancement in object storage, which allowed for the total size of content that could be stored in Amazon S3 to be lifted from 5 gigabytes up to terabytes. And what that meant is that it was now possible to take a lot of the large media content that this industry works in and store it natively in S3 as a single addressable object. The downside of that, or the other remaining problem with that, is that the only way to do that from a software perspective was to use something called the multi-part transfer API, which essentially builds upon the HTTP native interface to the object storage to allow for opening up parallel HTTP connections and posting in chunks of that file data piece by piece. And interestingly for us, as a transport company, our own customers in that area, including Amazon Video themselves, were challenged by trying to interface that to some type of high-speed transport over the WAN. And specifically, this is what so the specific problems that come up with that are that the object sizes, for example, are typically small. These large data sets have to be divided into chunks, and then they have to be posted in directly into the object storage. And that type of access requires using standard HTTP directly over the WAN, which is slow at distance. And it also means that the multi-part APIs have to be used by the application in order to get the files in and out. So as you see then below, for media and entertainment customers trying to deal in these large files on a regular basis, this is really incongruent with being able to be efficient and also to do this at ease at distance. And then the specific problem looks like this: either a single HTTP stream end-to-end into the object store, or in the case that Joe described, using the multi-part API to open up an HTTP connection for each one of the chunks that goes in parallel. And if you use one of the tools that's available in terms of the freeware, many of them open up parallel HTTP sessions and post the file data in this way, addressing it as a single object through the multi-part APIs. And that applies on upload and also on download. So essentially what we've done is create a new layer of software that allows for interfacing directly with the object storage in FASP as a protocol. And the way that you experience that is through Aspera software deployed directly on the Amazon cloud. We can run that software on an EC2 instance, and the backplane of it in the transport session talks natively to S3 using the native S3 APIs. The important point over the WAN is that classic TCP bottleneck that happens over the wide area is displaced by use of a FASP session. And then in memory, the data flows between that native layer of I/O that we've built directly to S3 and the transport session. End-to-end, that is able to achieve the line speed availability at global distances, and the customers that we work with now use that in order to transfer data to and from EC2 instances. In practical terms, that's good for 700 to 800 megabits, as Joe said, per extra large EC2 instance at global distance, and for more throughput, you simply add more instances. And the interesting point on that is the limiting factors there aren't so much the per host, but just the available bandwidth in and out of the wide area connections you get into EC2. The other thing that's interesting is on the client side, all of the standard Aspera clients work now natively with that. So actually the Shipping 3.0 software has built-in connections to S3, and then also on the security side, the secure boundary, something we call a document root in Aspera vocabulary, is preserved across the object storage. So on the back end, that I/O layer actually authenticates itself using configured S3 credentials so that the user's access is protected based on the security credentials to that particular storage. Also over the wire, the transfer is encrypted, and also you can choose to use Aspera's encryption at rest that leaves the files encrypted when they're stored as well, and also integrates on a distribution and download. In terms of the speeds here, just to make the point, at these types of speeds, you're looking at being able to move 10 terabytes per instance in 24 hours. And to put a fine point on that, we've all referenced Netflix. In particular, they have moved to kind of a massive model. At this point, they're over 100 terabytes of transfer a month with our software in and out of S3. So it's quite astronomical. And the comparison is to single HTTP stream or multi-streams, which are in the tens to hundreds of megabits over a US-based connection and will be slower than that at longer distances. So specifically, how do we offer this? The Aspera offering on Amazon is really designed to give a platform for the serving capability that can be directly integrated by any application that needs to ingest content or also distribute it. And then in addition to that, we provide our web applications, Shares and Fastbacks, as front-facing apps that users can use for upload and download and distribution. And one of the cases I'll talk about in a minute use Fastbacks for distribution directly off the cloud. In other cases, people use Shares for file browsing and access. And also all of the Aspera clients also are available as part of the offering. It's offered on a bytes transferred based subscription service, so there's no licensing, no user counts, or any other limitations involved, and we feel like that's working very well for our customers to be able to have freedom to elastically scale up and down their usage without having to worry about traditional kinds of enterprise capital expenditures. And that we think is also very exciting for continued growth and things like being able to ingest directly to Glacier as well. And in our software environment, some of you that use the products know that there are a variety of transfer software applications. All of these, from the core enterprise server through the Fastbacks through Shares, can be run directly on the cloud, reading and writing data directly from S3, and also in the Shares and Fastbacks context, some of the nodes can be both on-premise as well as on the cloud, so you can mix and match a hybrid on-premise with a cloud-based model, and I'll show that in a minute in a couple of demonstrations. So in summary, the way that we offer our on-demand offering is both as a bytes transfer-based subscription with automatic scale-out capacity based on how many instances you choose to run, no perpetual licenses, it's based on gigabytes transferred alone, and it also gives you flexible storage options for both local EBS as well as S3 storage. So I wanted to go through a few use cases of how customers can take advantage of this. The first one is a direct, simple Aspera transfer with an ingest from an Aspera server or client that you might already have. The 3.0 software is enabled, so now you can simply set up a connection to S3 directly within the connection interface and transfer to it using your S3 credentials. You can also create a private opaque area and then share out credentials to that with your partners as well. And that replaces, of course, the multi-part upload that you might use through a shareware tool. And this is just a quick screen capture of the new interface with connection settings directly for Amazon S3. I'm going to spend a little time also talking about the web experience. Aspera Shares is a web application that allows for having distributed storage nodes and then being able to offer upload and download with easy fine-grained access control. And any one of those nodes can be an Aspera server directly talking to S3 as well as on-premise. And that's really terrific when you're thinking about a use case like this, where you might have some of your storage stored in your own data center, some of your storage on Amazon S3, and your clients anywhere else in the globe. You might also want to mix and match that over time, and the Shares application gives you a virtual interface where to the end user, it is not visible where they're uploading and downloading. They just see the share locations that have been made available to them. Another use case has to do with ad hoc collaboration and distribution, for example, through Aspera Fastbacks, which is a web app that supports an email-style model. Users upload, exchange with the email addresses, download through links. They can also upload directly through Outlook now, through mobile clients, directly for iPhone or iOS, and also direct download to the desktop through Cargo. I want to make a couple of key points about this. Firstly, through our on-demand offering, Fastbacks can be run directly on EC2, where the user is simply uploading directly, and S3 is used for the storage and can also download directly for distribution. Beyond the classical model, also our current Fastbacks release 3.0 also supports publishing from remote storage. So an end user located anywhere can go to the Fastbacks interface, whether it's hosted on-premise or on the cloud, browse a remote storage location, which itself can be on the cloud, pick files, publish those. They go in the publishing step to the Fastbacks server. Links are created for download. So you have a completely distributed model where user is distributed from where the storage is, from where the distribution point is. It's just built into the way the software works. I I want to now talk a little bit about a very exciting use case that we were involved in this summer, and I think this is representative of what the cloud offering can do for media and entertainment. Specifically, this is the UEFA Euro 2012, which was the soccer championship, as we would call it, in the United States that took place between May and June. And the concept here, of course, was to do an all-file-based workflow, but specifically, UEFA decided that they would do the distribution of content to broadcasters. That would be the game highlights, both the low-res proxies as well as the high-definition clips that would be shown to us over air off of Amazon. And then our software at Aspera was used throughout the entire process to provide the ingest of content from the matches at the venues, the processing and orchestration, and then the upload to Amazon, and finally the distribution using Aspera Fastbacks. And I call this out because it was a very interesting use case of combining together on-premise infrastructure with the cloud and an extremely effective workflow. Those of you involved in this kind of business know how much revenue and reputation is at stake in an event like this, so everything had to go off without a hitch. Also, the UEFA's position on infrastructure was that for a short-term event like this, they needed a lot of bandwidth to achieve the SLAs on delivery times that they had promised to the broadcasters, but didn't have or want to have the capital and the means to invest in the bandwidth as well as all the hardware in order to pull this off. So they relied on the cloud to be the high-performance distribution point throughout this, and then invested in some on-premise hardware where our server software ran for collecting in the assets in the beginning and doing the workflow preparation through EVS and then ultimately publishing out to the cloud. And to share with you exactly the extent of this, it was quite exciting. I mean, in terms of clips, as far as clips transferred from the venues to the EVS system for preparation for distribution, there was about 7.2 terabytes. So that would be sort of traditional ingest done on premise. 1,703 video clips and about 1,200 audio clips, including 5 terabytes, were transferred up to S3 using our software, so a non-traditional ingest to the cloud. And there were about 10,000 workflows that were executed in that process in order to provide the notifications throughout that, which evolved into quite an elaborate set of workflow steps. That was done with the Aspera Orchestrator. And then finally, out of the distribution itself was 14 terabytes of data off of Fastbacks to all the broadcasters. And the average rates of these were somewhere between 70 and 300 megabits a second, depending on the bandwidth that the broadcaster had. And they were spread all over the globe, Japan, Europe, North America, South America, et cetera. So this was what the console looked like through the process. Little illustration of the products used through the distribution all the way out to Fastbacks On Demand on AWS. A little bit on the screenshot. This was the front end where broadcasters ordered content in order to download, and actually a third party named Delta Tray built that web portal, and they used the Fastbacks APIs to publish content from S3 to the Fastbacks server when an order was placed through the portal. So it's a very dynamic system. And that then brings me back to my final example, which is how this all can flow into end-to-end workflows. And I think the UFC will give you a much more vivid taste of this in terms of how they do this on a regular basis. One of the great openings that the cloud has given us in media is the ability to take advantage of its scale-out capacity. And transcoding in that way is transforming, as is also distribution. So this is an example of high-speed ingest into parallel or scale-out transcoding on the Amazon cloud, and then content available for distribution after the fact. That process is really transformed what we understand to be more traditional ways of doing transcoding, where you might do a completely serial process, and then when the final content in the transcoding itself, which might be hours as opposed to minutes, and then in the final distribution, that in itself in traditional methods wouldn't necessarily reach users at high speed, and also puts all the load on your own bandwidth. So this is a way to exploit the cloud to do this in minutes. And as an example, upload of 1 gigabyte file off of a high-speed colo to transcode is something like a minute. at the speeds we're talking about, and then the transcoding workflow takes over. And then finally, in terms of our products, we certainly offer distribution and download that has access control for the end users to take advantage of. So just the last couple of minutes, I'll just share a quick demonstration or two on this for you guys. And I have my Rackspace Colo for some high speed. So this is very simple, the classic Aspera client. And I'll start here. This is the, I like to use Cloudberry because it's a good example of a traditional tool that you might use for transfers. In this case, I'm browsing Amazon S3, s3.asperasoft.com. These are some of the buckets that are configured. And I'll show as an example just transferring this particular 5 GB file. So this is an application that uses the multi-part upload in order to do the transfer. And the typical transfer speeds for something like this will range between 20 megabits and 100 megabits a second, depending on the time of day, and that's typical. Right now it's at 30 to 40 megabits a second, crawls up here to 50, falls back down to 40, right? So we're on a Rackspace Colo that has 500-ish megabits a second of effective bandwidth. So we're using about a tenth of it right now for this single job. And this particular program, Cloudberry S3, I read opens about 15 parallel HTTP sessions to post these large files into S3. So sort of best case scenario. The other thing I would note is this particular Colo is only in the middle of the United States going to East Coast Amazon. If this client were even farther away, of course, the latency and loss would impair the speed further. So this is a traditional way of doing things. All right, so let me now just give a quick overview here. So in this case, this is a very classical client from Aspera, and this is the Amazon S3 setup that I've created within it. And I'm just going to do a simple transfer of that 5 GB file here, and you can see what that's like in terms of this particular connection. It will be between 500 and 600 megabits a second. And the key point for everyone here is it's the same kind of experience that you would normally have when you're going over the wide area with our software. On the security side, you can also turn on encryption, leave the file encrypted at rest, and then this same model that I'm showing here with the desktop client applies as you start to use Fastbacks, either for remote publishing or just running Fastbacks on the cloud, or using Aspera Shares if you want to use file browsing and distribution, for example. It's also designed to work with small files, so if you have large sets of DPX frames or something like that, you have the opportunity to send those as well. I think I've well exhausted my time, so I'm going to stop there, and if anybody has any questions after the fact, be happy to take those. Thank you.
Good job. Thanks. All right, so obviously the partnership between S3 and Aspera is really strong, and I think it's a good time now to dig into what it means when the data is actually in S3. When we think about our storage, we think about it in terms typically of block or file, and obviously in the media sector, files rule. That's where all our growth is. But then not only do you have your original copy, your origin copy, but you also have to think about archive, backup, and DR. And the reason I bring this up is when you have an object in S3, that object is sitting in one of the most durable storage subsystems on the planet. Reason being is S3 offers an SLA for durability of 11 nines of durability. So statistically what that means is if you put 10,000 objects in S3, you can expect to lose one every 10 million years. Fortunately, we've not lost any objects in S3 in our 6 years in business. So this is extremely durable. So when you're thinking about putting data in S3, don't just think about just the origin storage. Think about these other tiers, because we have archive tiers. And within those tiers, we have software, hardware, and resources to manage them. Same thing for your backup. You have software, hardware, and people to manage it. And same thing with DR, which can be very expensive. In fact, sometimes as an application owner, you have to choose no DR as your DR. So when you think about S3, you got to think about how highly, highly durable this storage subsystem is. Now, for some of us, we don't need that kind of durability, right? Maybe you're in the business of distributing MP3s or something that's easy to replace. It's not your single source, perhaps. Maybe we're a second or third copy for your business for some reason. In which case, we offered a trade-off to our customers a number of years ago by introducing reduced redundancy storage. Almost unfair to call it that because it is still durable, 4 nines of durability. So for those same 10,000 objects in RRS, statistically, you could expect to lose 1 every year. So you want to make sure that you're using this tier correctly, but there's a trade-off of cost. Right? We lower your cost by about 30%, and we offer you a little bit lower durability for those assets. And it's not an all-or-nothing proposition. We see a lot of our customers use S3 and RRS interchangeably. The performance is the same. It's just the durability that's different. Now, in terms of how we achieve that durability, most of you are familiar with the concept of regions. Werner threw up the chart up there and showed you that we have 8 regions around the globe. This chart is just representative. It's not a physical depiction of our availability zones by region. But let's just take an example of the top left-hand corner, which is the US East region. You have 3 availability zones shown there. Now, typically, if you're going to use AWS, you pick a region. That's choice number 1. Then you say, OK, what availability zone do I want to build my application into? Choice number 2. Then if you want a HA configuration, high availability configuration, you might choose to load balance between 2 availability zones. Right? These are choices that you make. Right? There's going to be a cost to having a highly available config like that, but you make those choices as a customer. With S3, you don't need to make those choices. Every object that you put into your availability zone or in your region, multiple copies will exist in every single AZ across all AZs in the region. And that's how we achieve that 11 nines of durability. Each AZ, by the way, is our fancy term for a data center. So these are geographically distinct data centers on separate floodplains, separate power grids, et cetera. So your data is dispersed geographically. So that's how we achieve that durability. Now with RRS, the only difference in the configuration is fewer copies are made within the AZ and across fewer AZs. So you still have a durable copy. Now this is a good trade-off that we have between S3 and RRS for our customers, but it wasn't enough. Right? We've been talking to our customers for the past year and a half, and our customers were saying, although I like the trade-off of durability for lower cost with RRS and S3, there are other use cases where I cannot trade off durability. I want a trade-off. I want lower price, but I don't want a trade-off of lower durability. What they were asking for, many of our customers, was a trade-off of lower cost for longer time to first byte. So think about your long-term archive. Right? Oftentimes, especially in the media sector, eventually your data, as it gets older or less important, long-tailed data, gets moved to tape. In some cases, it gets moved off-site to salt mines or an Iron Mountain facility. And your retrieval time can be quite long. So our customers are saying, look, we don't like tape. Right? I'm sure you've never experienced this, but sometimes you can't get data back from tape. It's not very durable. So our customers are saying, we want a trade-off, and we want very low cost. Werner mentioned S3 Glacier, which is shown here. And the trade-off here is now lower cost for longer time to first byte. So for a penny a gig, you have choices now. Penny per gig, you can get the same 11 nines of durability as S3, so distributed the same way, but for only a penny a gig. But it will take about 3 to 5 hours to get your file back, which in many cases is a great improvement over what it takes to get a file back from tape. So now you've got an HSM picture forming here that we want to enable for our customers. You've got S3, you've got RRS, you've got Glacier, and then you go on and think about how you use those tiers, right? Because Glacier, now that we layered in there into the storage tiers, we now have an ability to HSM the data for you. HSM's a term for hierarchical storage management. So I'm going to talk a little bit more about that in a second. But let's take a look at the pattern of using Glacier versus current systems today. Right? So we have, let's say, an A-lister. John Travolta becomes super popular, and Welcome Back Kotter episodes are the greatest thing, and you want to pull them out of your long-term archive. So your typical process is going to be, okay, let's go off-site. Let's get those tapes back. Right? Let's get them into our library, and let's bring them back up and restore those assets. Hopefully, they're intact, and hopefully, you have the hardware to restore that object. If this thing was 10 years old, let's say, you might have backed it up on DLT. Do you still have a DLT library? Do you have to get on eBay and go buy that library in order to read that file? So in some cases, you're calling back an 8-track, which is great. You have the data, but can you read it? So let's say you can read it. You do have the assets. That's fantastic. You call back the assets. They're intact. OK, good. Right, now let's put them into our digital asset management system. Let's transcode them for the next Xbox or whatever, however we want to distribute that. And let's get it out in the marketplace and let's monetize that. This is a process that can take days or weeks in some cases. The average SLA for a callback from Off-site storage with tape is about 4 days. So we want to change that, right? You've got an asset that's been sitting in Glacier for 10 years. And the great thing is you haven't had to touch that asset in 10 years. You haven't had to do a tech refresh. You hadn't had to do a software upgrade, right? So it's sitting there, it's intact, it's durable, and it's ready to be monetized. So the asset becomes popular again, you pull it into an S3 bucket. From there, maybe you move it into EC2, and Mark will talk more about the different options you have to transcode it. Perhaps you decide to use Glacier and begin distributing it and monetizing it, and you can do this in hours, especially if it's coming back from Glacier. Minutes if the asset happened to live on S3 or RRS. So let's talk about that, where the data lives, where you put it, how long it stays there, and we get into this concept of HSM. So we released Glacier about 4 weeks ago. Maybe you've read about that as well. But what we pre-announced when we launched that was something called S3 Glacier. So Glacier right now is a standalone product. Use APIs to write in and out of Glacier. It's not natively compatible with the rest of AWS. You can use EC2 calls to bring your job out of Glacier and into EC2 when the job is ready. However, with S3 Glacier, we're going to have this integration layer with S3, RRS, and Glacier, and you'll be able to tag your objects with policies. So for example, let's say your current season shows are going up and going into S3, and you've tagged them with a policy to live in S3 for 6 months, let's say, as an example. Once that policy is expired, you can have that will automatically move those assets into Glacier, where they can live for the next 17 years and be automatically deleted, or they can live in Glacier for eternity. So now we're creating this ability for you, the customer, to manage your policies yourself, set your own policies, and have the data automatically, without even thinking about it, move down into the next lower cost tier, depending on the asset and when it becomes aged or long tail. Enabling that for you, which is something that many customers have implemented themselves, but it's complicated to manage and it's expensive software that you need to run it. So we're going to enable that for you. So that's been pre-announced. That should be out in about 4 to 6 weeks. You'll see S3 Glacier announced, and we look forward to seeing what our partners do in order to integrate that and make it even more seamless for you, the customer, to enjoy that HSM experience and save yourself a lot of money over time. So some scenarios. I think we just covered this, right? Automatically age off to Glacier for permanent archive. Click at any time to bring it back into S3 and monetize it within the rest of AWS. And then, of course, you can always use CloudFront for distribution. Now, one thing that we'll also announce is that this is going to be a bi-directional service in terms of managing the policies. So in the case where we do have the A-list actor that becomes popular again, is a 10-year-old asset that you pull in, you monetize, you can set a policy for how long that lives in S3 so that you don't forget, right? You might take a number of jobs, pull them out of Glacier, and then you're working on them. You don't want to remember, I got to go back and put those back into Glacier. I don't want to incur those costs of S3 over time. So it's bi-directional. You can set that policy so that once it comes out and goes into S3, you monetize it. Let's say you tag that with a policy for, let's say, 30 days, and then it goes right back into Glacier. And we also expect to see our partners start doing some very creative things using these policies. You can imagine, if you will, an object that you wanted to keep durable. So let's say RRS is not an option for you because you want the 11 nines of durability, not the 4 nines for RRS. You can imagine a scenario where you do a put into S3. Let's say that lives there for 24 hours and then automatically expires. In that 24 hours, you can imagine yourself doing 2 copies, one to RRS, one to Glacier. Now you've got a durable copy on RRS because it's backed by Glacier, so you've saved yourself 30% over the cost of S3, and you can have a policy on that asset sitting in RRS to expire in 30 days, 90 days, a year, however long it is before your asset becomes long tail and stops being hot. In which case, you then delete it from RRS and it lives exclusively in Glacier. So this is the concept that we're going to enable with S3 Glacier, and I'm sure there are a lot of questions about the behavior of Glacier. You might have questions about the restore time. It's about a 3 to 5 hour restore time, and we collected a lot of requirements from our customers when we were coming up with Glacier in terms of how quickly do they need the asset back. And we got a lot of answers, and they were a wide range of SLAs from an hour to 24 hours to 4 days. So we settled in on 3 to 5 hours for the restore time from Glacier. However, we're putting control in the customer's hands in terms of the cost of that restore. So if you look online, you'll see that to restore from Glacier, you can restore up to 5% of your archive at no cost. And that's prorated over the course of the month. So I'm going to be releasing a TCO calculator so that you can get online, you can learn about the cost, the total cost of ownership with Glacier, because it won't just be about the penny per gig per month, right, which is a petabyte for $10,000, unheard of, very disruptive technology. But you'll be able to get online, take a look at a TCO calculator, take a look at your total archive size. Let's say you have 100 terabytes. You might maybe take 2 or 3 terabytes out per month, and you can calculate the cost of what that would be. However, if you decide you can take more time before you need that asset, let's say you said, using the API calls it, I can wait 3 days before I get that asset back. You can get your retrieval costs down to almost nothing. So we put that control in you, the customer's hands, how fast you need it back, what the cost will be, what percentage of the archive are you accessing, right? Glacier archive solution should be used for write once, read very infrequently files. But we're putting that control in your hands, and we expect over time our partners to abstract that from you, perhaps automate the process, giving permissions to certain people that restore a file that will, 100% of the time when they ask for a restore from Glacier, that file will be optimized on restore, so the cost is low. You can imagine other folks being authorized to do a fast restore and accept the charges for that. But look for the TCO calculator to come out on the website in about another week. And I think we've made up some time. I'm available for questions, deeper dives into Glacier, so please just ping me out in the hallway, and look forward to talking with you.